I want to talk to you in this video about the split brain patient. I'm doing this because even though this is in chapter 2 and this week is about states of consciousness, this seems to fit. The brain scanner reveals interesting facts at a Psych 1 level about how the mind works, and so does this experiment. So what is the basic experiment? Well, the first thing is that Roger Sperry and his colleagues studied a series of patients that were treated for epilepsy by dividing the connections between the two hemispheres, something called the corpus callosum. Now, if you look in figure 2.10 from chapter 2, you can see a diagram. In fact, let's take a look at that diagram now. So I want you to take out your textbook and look at figure 2.10. Now, figure 2.10 shows how the left and the right hemisphere represent the different hands. There's a cross, so the left hand is controlled by the right hemisphere, and how they have separate functions. On the left side, you tend to have language functions, particularly in right-handed male patients, like me, your professor, and on the other side, you tend to have spatial functions. I'll come back to this in a second, but please keep this diagram out so you can refer to it while I'm talking. Patients really did get some marked improvement. The epilepsy, which was spreading back and forth between the hemispheres, could not do that anymore after the corpus callosum was sectioned. But what was really remarkable was the cognitive function, because it really seemed for a while like there were two brains in the head. The one on the left is the one that I'm using to talk to you now, and it's the one that does language. The one on the right seemed to do more holistic functions, Gestalt type things where you see the entire pattern. A good one is your recognition of my face. That is something that is very strong in the right hemisphere and not so strong in the left, which raises an issue if you see me on the campus walk and you want to say, "Hello, Professor Stellar," using your left hemisphere. You must be communicating back and forth between the hemispheres. That's exactly what's happening. And perhaps that function might be a little disrupted if you had a split brain patient syndrome, that is, if your corpus callosum was cut. But other than something like that, these patients don't present any anomalies. They walk okay, they can button their shirts, they talk all right, it seems, except when they're talking to you, they talk only from the left hemisphere. And that's an interesting insight into states of consciousness that I want to proceed to next. However, before I do that, let me show you another picture from the textbook, which involves a very simple machine that you can use to isolate these functions. This is figure 2.11. And you notice that it has a picture of a patient looking at a fixation point, the dot in the center, while something is flashed. In this case, pair is flashed to the left visual field. And the subject would see pair in the right hemisphere. You can see that back here in the diagram on the right hemisphere side. So here's an experiment that I find fascinating. They flash to the left visual field one stimulus and to the right visual field another. The right visual field is a ball, and the subject immediately recognizes it and immediately says, "ball." On the other side, they have a key. Now this goes into the right hemisphere because it's coming from the left visual field. Remember, everything crosses. And the right hemisphere cannot speak, but it controls the left hand. So the subject has been instructed to reach under the table, as you saw in the diagram, and find an object that corresponds to what it sees. What happens is remarkable. The subject, the patient, has just said the word ball, but finds himself holding up his left hand with a key in it. And the experimenter asks, "What are you doing with the key in your hand?" Quick as a wink, without thinking, the language hemisphere on the left says, "Oh, well, that's a key because you need a key to get into the cabinet where the balls are kept." So that's called confabulation. Patients do that. You do that. If I ask you an essay test on an exam and you don't know the answer, but you know I give partial credit, you throw something down. But you know you're doing it. In this case, it appears that the left hemisphere doesn't even recognize. It just says something that seems to make the best sense out of what it has just seen. which is its own left hand holding a key after it heard itself say, ball. The left hemisphere is what is speaking to you. The right hemisphere snuck in there because of the way this experiment was constructed using this device, which is called the phthistoscope, to flash objects separately into each visual field. If you don't understand the machine, take a look at figure 2.11. If you don't understand the brain diagram, look at figure 2.0. But we want to talk about this in terms of consciousness, because it does look like you have two streams of consciousness inside your head, one language, one spatial. What if this is extended to other things? There's a case, for example, with Michael Gazzaniga, who was a colleague of Sperry's, where he went to a party with split brain patients, and one of them picked up an axe with one hand and acted menacingly towards him. He saw the other hand then go to the axe, and a seesaw battle ensued as the two hands wrestled for control of the axe. Gazzaniga is supposed to have said at that point that he left the area, not wanting to be the first test case in the state of California for whether you can incarcerate, let's say, the left hemisphere for something the right hemisphere did. So this brings this split brain patient right into states of consciousness. Talk about it in class.